Isaac Newton, the discoverer of gravity and critic of the Holy Trinity, an English scientist considered one of the foremost pioneers of the scientific revolution in the 17th century, which later paved the way for what became known as the Age of Enlightenment. Despite gaining fame for discovering the laws of motion and gravity, he made numerous other scientific achievements in diverse fields such as physics, mathematics, astronomy, optics, and theology. His accomplishments made him one of the greatest and most influential scientists in history. Isaac Newton was born on January 4, 1643, in a small village in Lincolnshire, England. He was orphaned at a young age when his father, also named Isaac Newton, passed away 3 months before his birth. When Newton was 3 years old, his mother remarried and went to live with her new husband, Reverend Barnabas Smith, leaving her son in the care of his grandmother on his mother's side. Newton harbored resentment towards his stepfather and also held some animosity towards his mother because of her marriage to him. Newton was born an orphan and grew up with his grandmother. After his mother Getty remarried, the 28th of January 2024, an English scientist considered one of the foremost pioneers of the scientific revolution in the 17th century, which later paved the way for what became known as the Age of Enlightenment. Despite gaining fame for discovering the laws of motion and gravity, he made numerous other scientific achievements in diverse fields such as physics, mathematics, astronomy, optics, and theology. His accomplishments made him one of the greatest and most influential scientists in his story, birth, and upbringing. Isaac Newton was born on January 4, 1643, in a small village in Lincolnshire, England. He was orphaned at a young age when his father, also named Isaac Newton, passed away 3 months before his birth. When Newton was 3 years old, his mother remarried and went to live with her new husband, Reverend Barnabas Smith, leaving her son in the care of his grandmother on his mother's side. Newton harbored resentment towards his stepfather and also held some animosity towards his mother because of her marriage to him. Education and scientific formation. Newton received his education from the age of 12 to 17 at the King's School in Grantham, which taught Latin and ancient Greek. However, his mother decided to withdraw him from school to return to the village and work as a farmer, a profession that Newton strongly disliked and refused to work in. Finally, his mother relented and allowed him to return to school after becoming frustrated with forcing him to work. Upon his return, he distinguished himself as the top student among his peers, known for his inventions and construction of various models of sundials and windmills. In June 1661, Newton was admitted to Trinity College, Cambridge, where he completed his undergraduate studies and obtained his master's degree. Newton's name is associated in many minds with the apple that fell on his head while he was sitting under the tree, and that apple was the reason that led to his discovery of the law of gravity. And despite that, historians differed about it, some of whom counted it a legend, and some of whom affirmed its occurrence. But it is certain that he discovered gravity and put its basic laws. Newton began developing his theory of gravity in 1665, then focused his attention on studying its effect on the orbits of planets in 1679 and found evidence proving that the elliptical shape of planetary orbits results from a central gravitational force that varies inversely with the square of the semi-major axis. Newton sent his results to the famous astronomer and mathematician Edmund Halley and to the Royal Society in his book on the motion of bodies and orbits. The book contained the core that Newton developed to form later the book Principles, which was published on July 5, 1687, with encouragement and financial assistance from Halley. Newton's book Principles is considered one of the main reasons for his fame. In this book, Newton discussed the three universal laws of motion that describe the relationship between any body, the forces acting on it, and the resulting motion, and these laws form the cornerstone of classical mechanics, as well as contributed to many developments during the Industrial Revolution. Newton introduced a method similar to differential and integral calculus for geometric analysis, using first and last ratios, and gave the first analysis based on Boyle's law of the speed of sound in air, inferred the flattening of the spherical shape of the Earth, studied the motion of the Moon and its effect on the Earth, presented a theory to determine the orbits of comets and others. One of Newton's most famous achievements in mathematics was his theory of differential and integral calculus, but it caused a lot of disputes and controversies at the time, as the English mathematician John Leibniz discovered the laws of differentiation and integration during the same period, and the two sides argued about the legitimacy of this discovery, and the dispute reached its peak in 1711, when the Royal Society announced in a study that Newton was the true discoverer and Leibniz was described as a fraud. Historians later accused Newton of abusing his position and status in the scientific society to pass this announcement, and many of them believe that both Newton and Leibniz independently reached the discovery of differential and integral calculus at the same time, although some historians favor the idea that Newton preceded Leibniz in this discovery, as it relied on Leibniz's notation, and his method was considered more convenient for many mathematicians later. Aside from differential and integral calculus, Newton made many contributions to mathematics, including the classification of cubic plane curves and contributions to the theory of finite differences. He was the first to use fractional indices and used coordinate geometry to derive solutions to Diophantine equations. Apart from the scientific fields, Newton also made significant contributions in optics. In 1666, he observed that the spectrum of colors emerging from a prism at the minimum deviation straight, even when a circular light ray enters it, meaning that the prism breaks down into different colors at different angles. This led him to conclude that color is an essential property of light, a point that was until then subject to debate. Between 1670 and 1672, Newton delivered numerous lectures in optics. During this period, he studied the refraction of light, explaining that the multicolored image produced by the prism, the spectrum, could be reconstituted into white light by a lens and a second prism. Newton concluded that any refracting telescope lens would suffer from light dispersion into color's chromatic aberration. As evidence of this concept, he built a telescope using reflecting mirrors instead of lenses, which was the first functional reflecting telescope known as the Newtonian telescope. Among the estimated 10 million words written in Newton's papers, there are approximately 1 million words written in the field of chemistry, but many of his writings in chemistry are copies of other manuscripts, with his own explanations added. Apart from scientific fields, Newton was also active in theology. In the 1690s, he wrote several religious articles dealing with the literal and symbolic interpretation of the Holy Scriptures. One of his most famous works in this field is a manuscript he sent to the English philosopher John Locke, casting doubt on the validity of the Johannine comma, a phrase believed to have been interpolated in the 5th chapter 5:7 of the Gospel of John. Newton's manuscript was not published until 1785. Newton was known to record his theological research in notebooks that he did not show to anyone, and when later accessed, they demonstrated his extensive knowledge of religious texts. Newton was known to be opposed to the idea of the Holy Trinity, as he believed that the worship of Christ is no different from the worship of idols, and classified among the major sins, and because of that, many historians accused him of heresy. Newton held many prestigious positions in England. 1. He was a member of the English Parliament for the University of Cambridge between 1689 and 1701. 2. He assumed the position of Warden of the Royal Mint in 1696. 3. He later became the Chief of the Mint, a position he held in the last 30 years of his life. 4. He was appointed President of the Royal Society in 1703 and a member of the French Academy of Sciences. 5. In April 1705, Queen Anne bestowed upon him the title of Sir during a royal visit to Trinity College, Cambridge, making him the second scientist to receive this title after the philosopher Francis Bacon. Among the governmental tasks assigned to him was the detection of counterfeit coins during their reminting, and Newton estimated that 20% of the metal coins seized during the major coinage reminting in 1696 were counterfeit. Counterfeiting was then a major betrayal, punishable by hanging and quartering. Although convicting criminals was extremely difficult, Newton proved himself equal to the task. He disguised himself as a bar patron, gathered much of that evidence himself, and conducted more than 100 interrogations of witnesses, informants, and suspects between 1698 and 1699, successfully trying 28 counterfeiters. In his final days, Newton resided with his niece and her husband, who cared for him until his death on March 20, 1727, in Cranberry Park near Winchester, where a grand funeral was held attended by nobles, scientists, and philosophers, and he was buried in the Royal Westminster Church among kings and queens. To be the first scientist buried in his monastery after his death, his hair was examined, and it was found that he had been exposed to mercury, believed to have been affected by his chemical experiments. He was poisoned by it until he died.